Hello friends, let's start third topic from design of steel structures, design of steel and RCC structures, that is DSR. The third topic as per EMSBT syllabus, we have analysis and design of singly reinforced rectangular sections. Okay. So, in which the first or the syllabus for this particular topic is limit state of collapse and their assumptions, then strain diagram and stress strain relationship for concrete, and also block diagram for singly reinforced section that we have to study, and then under reinforced, over reinforced and balance sections, their difference we have to study here. Then the IS specifications regarding to spacing, cover, minimum reinforcement, effective span in beams, that we will cover in this particular topic. So the limit state of collapse in flexure is nothing but the resistance to bending at every section shall not be less than the appropriate value at that section produced by the probable most unfavorable combination of loads on the structure using the appropriate partial safety factor. Okay, so the assumptions in design for the limit state of collapse in flexure are the assumptions. Okay, assumptions in design for the limit state of collapse in flexure. First one, the plane sections normal to the axis remain plane after bending. Okay, then the second, the maximum strain in concrete. Second assumption, the maximum strain in concrete at the outermost compression fiber is 0.0035 in bending. Then third assumption is the tensile strength of the concrete is ignored, as it is very less as compared to the compressive strength. Okay, the tensile strength of the concrete is ignored or it is very less as compared to compressive strength. Okay, then the formula, or before that, there is a perfect bond between, it is assumed that there is perfect bond bond between perfect bond between steel and concrete right up to the failure, right up to the failure of RC section. Okay, and the minimum strain epsilon s is equal to, this is fifth assumption, epsilon s is equal to Fy upon 1.15 Es plus 0.002, where Fy characteristic strength of steel, Es modulus of elasticity of steel, and that is always taken as 2 into 10 to the power 5 Newton per mm square. Okay, these are the some assumptions in design for the limit state of collapse in flexure. Okay, the next point here we will discuss, that is the strain diagram. Okay, strain diagram and stress block diagram for singly reinforced section. Okay, this is the diagram that I have already drawn here. Suppose this rectangular section having b, small b is width and small d is capital, small d is depth. Okay, this is a rectangular section of the beam having size b into d, and area of reinforcement or area of steel is suppose AST. Then for this, the strain diagram should be like this. Here epsilon Cu maximum strain at due to compression, and here maximum strain due to tension. Okay, then this is Xu is the ultimate or the ultimate distance from extreme fiber to the neutral axis. Okay, here the extreme fiber to the neutral axis distance is denoted as Xu, and at somewhere here the value small a from neutral axis is 0.002. Okay, this is strain diagram, and this is the nature of stress diagram, which is the combination of one rectangle and one parabola. Okay, so this value at the top is 0.45 ck, and this value is 0.42 Xu, and here is the maximum compressive force at this point, that is denoted as Cu, and at the bottom Tu, that is ultimate tensile strength and ultimate compressive strength. Okay, at this point. So this is A, and that's why this much distance is Xu minus A. Okay, this distance. From this stress strain diagram, we can easily derive some formulas here. By similar triangle from this strain diagram, 0.0035 at extreme fiber, that we have seen in assumption 0.0035 upon Xu is equal to 0.002 upon A. If we calculate the value of A from this, we will get A is equal to 0.57 times Xu. For a maximum compressive stress, the stress strain diagram shows 0.067 FCK upon gamma m partial safety factor that we take 1.5, and from this calculation we will get the maximum compressive stress is 0.45 FCK that we have shown here in the stress diagram, maximum compressive stress. Okay, that just we have calculated. Then likewise total compressive force CU. Okay, here total compressive force, area of stress block is equal to, for this diagram, area of stress block is equal to area of rectangular plus area of parabola. Okay, you can clearly see here rectangular part and then parabolic part. Just calculate the areas of both these diagrams. Area of rectangular plus area of parabola. Just simply area of rectangular 0.45 sec into xu minus a, and for parabola we have formula 2/3 into 0.45 sec into e. If we calculate this, we will get Cu is equal to 0.36 FCK XU B. This is the total compressive force. Okay, Cu, and similarly we can calculate total tensile force Tu. Tu is equal to area of steel into stress. Area of steel we have assumed here AST, then AST into Fy upon gamma m. If we put the gamma m for steel, that is 1.15, Tu is equal to AST into Fy upon 1.15, and if we put the value and calculate it, we will get Tu is equal to 0.87 Fy AST. Okay, and after that we have to compare simply Cu and Tu at neutral axis. Okay, if we compare the total compressive force that we have calculated and total tensile force, just compare these two formulas, we will get Xu is equal to 0.87 Fy AST upon 0.36 FCK B. Okay, this is the very important formula we will use for the design of singly reinforced rectangular sections. Okay, then from similar triangle we can just calculate here epsilon SU is Cu, total D XU, therefore D minus XU. From this diagram, just apply similar triangle formula and calculate the values. Epsilon SU we will get almost 0.0031 that we have already assumed in the assumptions, and once we calculate epsilon SU from this formula, we will get XU max is equal to 0.53 D for Fe 250, XU max is equal to 0.48 D for Fe 415, and XU max is equal to 0.46 D for Fe 500. Okay, and from that we have made this table. Okay, so this is the brief introduction about this topic, that is analysis and design of singly reinforced rectangular section. The remaining part we will discuss in the next video. Thank you.